My name is Ilan Sosnovitch, and I'm the Global Sales Manager for SIGA OT Solutions. I'd like to thank STE for organizing this important webinar and for inviting us to discuss level zero monitoring and understand why is that important for securing the resilience of OT environments. What is exactly level zero monitoring? What is process-oriented monitoring, and why is that so important for OT environments? I'd like to first discuss the challenges of OT system security. Many of the solutions today migrated from the IT world into the OT world. We see a network within the OT architecture, and we're saying, listen, we know how to protect networks. We learned that for many years in the IT world. Let's migrate the solutions from the IT to the OT. But there is a struggle, there is a challenge with that approach. Why? Because the very definition of what is an asset in IT is different from OT. In IT, the asset we're trying to protect is the data or the server that stores the data. But in OT, the very definition of what is an asset is different. The asset in OT is the critical machinery providing a physical process. That's why the definitions are quite different. Security for IT focuses on data integrity and security for OT focuses on process continuity and keeping the equipment intact. We can see here the different layers in the Purdue model that shows the OT architecture. We see the network layers, which are control networks, and they are, as used to say today, are vulnerable by design. And we're trying to secure that network to make sure that nobody infiltrates that network. That's very good. However, OT resilience begins with process health. We need to make sure that we're looking directly at the process and the equipment directly in level zero in order to make sure that they are secure. The OT systems, the cyber attack's main goal is to reach and impact the physical assets. If a hacker was able to infiltrate the OT network, but not get down in level zero to change the actual physical parameters in level zero, that's not much of an attack in OT systems. So the ultimate goal for cyber attackers is how do they impact the OT, the physical assets in level zero. And the question we need to ask ourselves is, can we really hack the hackers? Can we really find ourselves sealing off our networks so nobody will go in? And I think the premise that everyone has to have, any operator in OT environments has to have, is that PLCs will eventually be compromised. Eventually, someone will be able, if he's determined enough, to infiltrate the PLC. There are many, many ways where he can do that. So he can infiltrate the PLC and eventually compromise the process itself by changing the logic in the PLC. The PLC is the critical layer because it isolates between the physical area of the OT architecture, the physical area meaning the level zero area, the real assets where the physical process is actually happening, the turbines, the pumps, the chemicals, that's where the real world processes are occurring. And the digital representation of those physical parameters in the OT network, the HMIs and the engineering stations. So the PLC is a critical layer between those two representations, the real world representations and the digital representations. And PLCs, like I said earlier, if someone was able to infiltrate the PLC, an attacker compromised the PLC, he has complete freedom of action, essentially. He can change the logic of level zero machinery, and he can make damage to human lives or to equipment or to the environment by creating a different process than the normal behavior of the process. All this leads us to understand that we need a solution that's not only determined on the network side, but is also designed for OT itself. The solution that focuses on securing the critical assets directly from the process. This is why we believe in SIGA OT solutions, and we developed a solution that can monitor and protect the assets directly from the assets without being dependent on what's happening in the network, which is vulnerable by design. So how do we do this? Essentially, we built a very simple platform that's comprised by a hardware software solution that connects directly to level 0 signals. Here on the left, you can see the level 0 signals in between the critical assets, the sensors and actuators on the equipment side, and the PLC before these electrical signals are becoming digital protocols. And we're taking those electrical signals and we're connecting into them, we're duplicating them into our platform so we can analyze what's happening within the process. What we achieve by doing this is access to the most rich and reliable source of data in the OT network, but more importantly, it's unhackable by definition, because the best hacker in the world can only go down in the network to the PLC, but he cannot go down to the electrical signals because they're completely physical, they're not protocols. So that's why we found an environment within the OT architecture which is completely isolated, completely untouched, and cannot be manipulated by any hacker in any way. So in that way, we can focus on what's happening on the process, and we can make sure that the process is going as designed. When we acquire these electrical signals, we take them into our software platform in order to analyze them. First, we provide real-time monitoring and granular visibility into the OT process. But on top of that, we apply machine learning algorithms which analyze the normal behavior of the process. It doesn't matter which process it is, but analyzes what is the normal behavior of the process. And once an anomaly occurs, we will alert about that anomaly and provide the alert to operators for analysis and recovery. The alert can be a cyber attack, that someone compromised the PLC and changed the logic of the PLC. And it can also be operational failure. And that's something that could be helpful for operators in general. Our anomaly detection engine is comprised from different types of models, variation models, correlation models, prediction models that we created and developed in order to understand what is a normal behavior of a process and when can alert be fired in order to help operators understand when their process is compromised, again, either by a cyber attack or by an operational failure. Let's look at a very famous attack, like a STuxnet-like situation, where someone was able to infiltrate the PLC and change the logic of the PLC. He does this while giving a totally different representation in the upper layers that something was wrong. So the people on the HMI level or the operating station level, they think that everything is okay, but because the hacker was able to manipulate the data in the HMI to show that everything is fine, while a totally different situation is happening in level 0. In this type of situations, SIGA is the best solution because we are not manipulated by any type of an attacker because we're not part of the network. So we are only focusing on the important critical layer in level 0 without any compromise from the network level. The SIGA solution has been validated by different authorities worldwide, tested also by authorities. And we can say today that level 0 monitoring is something that's been accepted by top leading agencies and companies worldwide to understand that sealing off OT architecture includes level 0 monitoring for any type of holistic approach for OT cybersecurity. And that's exactly why we're very happy with the cooperation with STE, our partners in Singapore, that help us to make sure that operators in OT environments have a complete approach to multi-layer protection in the OT environments. We can also see here that the SIGA solution can provide like a SOC enabler interface where we can see multiple sites worldwide and correlate them into a single screen where we can analyze the situation in different sites simultaneously and very easily, user-friendly, in order to provide like a security operations center for operators of security solutions. If we look at different attacks, we can see in the past years, we can see that the water infrastructure specifically has been very vulnerable. There are many reasons for this. We've seen that in Israeli type of water facilities attacks. Just recently, we also saw it in Florida, where someone was able to make a very dangerous situation. And that just also underpins the vital necessity of level 0 monitoring. Because again, we can see that no matter how much we think that our infrastructure is secured and there are air gaps and isolated environments, there is never a 100% isolated environment. And that's why we need to have some solution that focuses on our critical assets. Some level, and the SIGA solution is built exactly for that purpose, to focus on level 0 signals, to focus on the process, the critical assets themselves, and make sure that they are operating according to their design without any type of manipulations coming from adversaries that infiltrated the system. So thank you again. I hope this was an interesting approach, and I'd like to hand it back to you. Go ahead.